Hello and welcome to another video of Smarty Academia International. Our today's topic is going to be on geometric sequence and series. This is a type of series in which we have a common ratio, which we will label as R, which means that if we have a series, let's say U1, U2, U3 until UN, this particular series have a common ratio, which means if we divide the consecutive terms, we will always get the same answer, which should be equals to R. Which means if we want to get the next term in the series, all we have to do is multiply by a common ratio, which is R. Now let's try to understand how we can write the general term of this particular series. For that reason, let's consider a series whose first term is 1, second term is 3, third term is 9, fourth term is 27, until UN. And we are looking to find a particular general formula to write the nth term of the series. Please note that this particular series is just simply generated by multiplying 3 with the previous term. And that's how we can basically generate the series, which means the common ratio of this particular series is 3. Now, I can write this the terms of the series in a different way. Let's say 1 can be written as 1 times 3 power 0. You would see that there's a reason for that. We know that 3 power 0 is 1, so 1 times 1 will generate 1. 3 can be written as 1 times 3 power 1. Similarly, 9 can be written as 1 times 3 power 2, and 27 can be written as 1 times 3 power 3, and so on and so forth. Now, I just want to know how I can write my nth term. If you notice, this is particularly same for all terms, which means I can write 1 here. Similarly, you can see that this is the 3 remains constant for everything, which means I can write times 3. The only thing that's changing is this 0, 1, 2, 3, and so on. And if you notice, for when n equals to 1, the first term, our power is 0. For n equals to 2, the second term, our power is 1. For n equals to 3, third term, our power is 2. And for n equals to 4, our power is 3. So similarly, for nth term, I can simply write here n minus 1. So this is what my general term looks like. In this thing, if you see this 1, this is simply U1, and this 3 is simply R. So the general term of this particular sequence, which is the geometric sequence, can be written as U of n equals to U1 and R power n minus 1. This is the general term of this series. Now let's use this formula to find the 10th term of the above example. For instance, we know that to find the 10th term, we know that our U1 is simply 1, our common ratio is simply 3, and the nth term which I'm looking to find is the 10th term. All I have to do is just substitute these things in my general formula. So my U of 10 will simply be U1 is 1, bracket, or is 3 power 10 minus 1, which is simply 1, bracket, 3 power 9. And if you use the calculator, you would see that 3 power 9 times 1 is 19683. So this was pretty straightforward. Let's try to use another example with a different common ratio. We can have, let's say, first term 96, second term negative 48, third term 24, fourth term negative 12, and so on and so forth. To check whether this is a geometric series, all I have to do is check whether we have a common ratio. So let's try to do U2 over U1. You would notice that negative 48 over 96 will give you negative 1 over 2. If you try U3 over U2, which is 24 over negative 48, the answer is still negative 1 over 2. So this means this is a geometric series with a common ratio of negative 1 over 2. Pretty straightforward. Now let's say if I want to find the 8th term of the series. So I want to find what is my U8. In the same way, I can just substitute the values in my general formula. For that, my U1 here is 96, my common ratio is negative 1 over 2, and the nth term, which I'm looking to find, is the 8th term. So just trying to find the 8th term by substituting these values in the general formula and just substituting in my calculator, it will just give me negative 3 over 4. Now the next step is to find the sum of the sequence for the geometric series. Please note, I can write my sum as U1 plus U1 R power 1 plus U1 R power 2 plus U1 R power 3 until U1 R power n minus 1. This is a consequence of this general term that we derived as Un equals U1 R power n minus 1. Simply, I put n equals to 1 the first term, I get U1, I put n equals to 2, I get U1 R1, and so on and so forth. Now, as I've written this series in a summation form, I'm looking to derive the formula for my summation. So if you notice, I can take U1 common from all of these terms, and the remaining terms are 1 plus R power 1 plus R power 2 plus R power 3 until R power n minus 1. Now, this particular term, which is the sum of the series, can be written in a different way, which is R power n minus 1 over R minus 1. Now, this is beyond the scope of our course, but I will post the link in the description where the proof of this thing is given. This is for higher level undergrad mathematics courses, and I will put the link in the description for this proof if someone is interested to know how this can be derived. So, the summation, the sum of the sequence of geometric series in the sigma notation form can be written as U1 R power n minus 1 over R minus 1. Please notice that this formula is valid if the value of R is greater or equals to 1 mod, which means that either your r is greater or equals to 1 or your r is less or equals to -1. In the case when your r mod is less than 1, or you have r between the value of r between -1 and 1, this particular formula just changes its shape and gives you u1 1 minus rn over 1 minus r. So both these formula have the same utility. It only depends on the value of r that which formula will be used. Although if you used the same formula for different values of r, it will still give you the same answer, but it's good to have these two different formulas for different values of r. So we have understood what is the general term of the geometric series, and we have also understood what is the sum of the geometric series. Now let's solve the questions. It says consider the sequence 2, 2 root 3, 6, and 6 root 3, and so on. I need to prove that whether the sequence is geometric or no. In order to do that, all we have to find is that whether the series has a common ratio. So let's try to divide two consecutive terms, u2 over u1. The answer is 2 root 3 over 2, and my final answer goes to 3 because my 2 and 2 cancels out. Now let's try to do whether the next two consecutive terms give me the same common ratio. u3 over u2 will be 2 root 3, beg your pardon, 6 over 2 root 3. Now, in order to do this, I just need to simplify my numbers first, and you can see my answer comes out to be 3 over root 3. You might get confused that these two terms, root 3 and these, are not same, but they are in fact. You can also use your calculator to check this, but there is a way of rationalizing the surds, because we do not write the surds in the denominator, and I can simply multiply and divide with whatever is in the denominator. Now, what happens is 3 times root 3 becomes 3 root 3, and root 3 times root 3 becomes root 9, which is simply 3. Root 9 is simply 3. And you can see my 3 and 3 cancels out, and I get the same answer as root 3, which means this particular series has a common ratio of root 3, and hence it is a geometric sequence. Now, in the B part, it says that find the formula for its general term. Now, once we've proved that it's a geometric sequence, we know that the geometric sequence general formula is un equals to u1 r power n minus 1. In the geometric sequence formula, general formula, whether you're doing for arithmetic sequence or geometric sequence, you must note that the only variable in the general term should be n. So we have to replace u1, which in this case is 2. We have to replace r, which in this case is root 3. So our u of n will become 2 bracket root 3 power n minus 1. Pretty straightforward. In this case, this is my general formula. Now, for the C part, it says find the 10th term. Simply, I can use the general formula to find my 10th term, and I can use my n equals to 10. So what's going to happen is u of 10 equals to 2 root 3 power 10 minus 1, which is 2 root 3 power 9. Now, if you look at the sequence, everything has been written in the form of root 3, like 2, comma 2 root 3, comma 6, comma 6 root 3, and so on and so forth. So I also wish to write my 10th term in the form of root 3, something x root 3 form. So this is how I will use my surds formula to work on it. So what's going to happen is I can replace my two surds, because I know that my am power n is simply same as n power n. So I can replace these things because both is same equals to m times n. Right? So I can replace my root and the power. Now, if I want to solve this, what's root of 3 power 9 from the calculator? The answer gives me 19683. Again, this was the formula this was the answer for my 3 power 9. The root is still intact. Now, further, I can write as, because I want to write in root 3 format, so I can write this as 6561 times 3. Right? And I can separate my roots now, which is 6561 times root of 3 is a multiply here. And you note that root of 6561 is nothing, but it's simply 81 times root 3. You can check this using your calculator. Now 2 times 81 is simply 162 times root 3. So this is my 10th term in the same format as the series is given. Now in the D part, the final part, it says find the first term which exceeds 1000. Now, which means that you need to find the nth term for which the term exceeds 1000. Please note that this 162 root 3 is nothing but 280.59 blah 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 blah. Now you need to find the term which term exceeds 1000. So in this case, I will just write the nth term formula, which in my case is 2 bracket root 3 of n minus 1 is greater than 1000. There are two ways to solve this. The first way is using technology, GDC, using your GDC calculator, which I will also post the video. So we have, let's say, x and y axis, and we have a certain graph of the exponential function. Let's say, and this is the graph, this is an exponential function that we are having for this. Let's say this is it. And this is your y equals to 2 root 3 n minus 1. Now I want to find for example, this is my 1000. I want to find what is the value of n. Remember, this is n and this is y. What is the value of n for which it exceeds 1000? So I can find this point of intersection and see for what value of n it exceeds. To solve this question using the graphing calculator. So here is one of the graphing calculators, Casio, and you have to go into the graph section. Then you have to write your equation, which in this case was 2 bracket root 3 power x minus 1. And you need to check if you want to draw this. Let's say this is the graph, exponential graph that it has drawn for you. Now you need to check where it will become 1000. So I can write the second graph as 1000, and I can go to my draw section. And if you see, it has given me one line and one exponential. I need to find this point of intersection where the graph goes into my 1000 and then crosses. So what value of n, the x-axis, what value of n my graph goes beyond 1000. So I can just use my gsolve and point of intersection, and if I do it, my enter, you can see my point of intersection is x equals to 12.3, so on, and my y equals to 1000, which means that after the 12th term, my term exceeds 1000. So the answer is going to be 30. The second method is the logs method, which I can just simply take logs of both sides. So I get, but before doing the logs, first I can take this 2 down. So my root 3 of n minus 1 is greater than basically 500, because 1000 divided by 2 is 500. Now I can take log of both sides. Remember, log, if it's simple log, it's base 10. Now I can use the rule of log, that log of x power m is basically m log of x. So what just happens is this m comes out from the power. So what happens is n minus 1 becomes log of root 3 greater than log of 500, and I can simply now do n minus 1 is greater than log of 500 over log of root 3. And if I use my calculator to do this, I get from here n minus 1 is greater than 12.3 something, and n should be greater than 11.3 something, and n should be greater than 1 goes to the other side, and it gives me 12.3 something. So means my n should be 13. The next whole number is 13, which gives me the same answer as my GDC, which means the 13th term is the term which will cross 1000. Let's see the next question. It says find the journal term of the geometric sequence when u5 is 324 and u10 is 78732. So let's try to do this question. Now we know that my u of n, the journal term, is u1 r power n minus 1. Now, if you notice, we do not have u1, we do not have r, which means we need to find this using two different equations. To find two variables, we need two different equations. To find three variables, we need three different equations. To find one variable, we need one equation. So let's try to use this given thing. So u5 is 324, which means my n is 5. So what will happen to my journal formula? My u5 will be equals to u1 r power 5 minus 1, which in this case is going to be 324 u1 r power 4. So that I can call this my first equation. My second given is u10 equals to 78732, which means my n in this case is 10. So what I can write is u of 10 is equals to u1 r power 10 minus 1, which means my u10 is 78732, which is equals to u1 power r minus 9. This is my equation number 2. Now I can divide equation 2 by equation 1. What do I get is 78732 over 324 is equals to u1 r power 9 over u1 r power 4. Now if you notice, we have eliminated one of the variables. Now 78732 divided by 324 will give you 243, which is equals to r power 9 minus 4, because we know that a power m over a power n is simply equals to a power m minus n. This is the exponent formula. Now, which means 243 will be equals to r power 9 minus 4 is 5. Now, in order to find r, I just have to take the fifth root of 243, which in this case is 3. So my r turns out to be 3. So I found my first unknown variable. Now I can substitute this value in any of the equations to find u1. So I can, let's say, substitute r equals to 3 in equation number 1. So I get 324 equals to u1 3 power 4, which is basically u1 is equals to 3 power 24 over 3 power 4. This whole thing comes down here. Now 324 divided by 3 power 4 is simply 4. So my u1 is simply 4. Now all I have to write the journal term, which is the demand of the question. And I told you in my journal term, my only variable should be n, u1 r power n minus 1. So that's why it was important to find r1 and r and u1. So u1 is 4, r is 3, and that's n minus 1. So this is my general term as required by the question. The next question says that k minus 1, k plus 2, and 3k are consecutive terms of a geometric sequence. Find the value of k. So we know that these terms, k minus 1, that's the first term, k plus 2 is the second term, 3k is the third term, and so on and so forth. So that's my u1, that's my u2, that's my u3. Now, because it's written that it's a geometric sequence, so you know that the common ratio is going to be same. So I can use this logic, this rationale, that my u2 over u1 is going to be same as my u3 over u2. And that's simply what I have to do. So u2 over u1 is simply k plus 2 over k minus 1, which is equals to 3k over k plus 2. So all I have to do is simply solve this equation using cross multiplication. K plus 2 times k plus 2 is equals to 3k times k minus 1. Now what happens is I just need to solve this. K times k is k squared. This will become 2k plus 2k plus 4. It's simply expanding the brackets. This will become 3k squared minus 3k. Now I can simply take everything on the one side, which is looking like a quadratic equation. So k squared plus 2 plus 2k, it will be 4k plus 4 minus 3k squared and plus 3k. The answer will equals to 0. K squared minus 3k squared gives you minus 2k squared, 4k plus 3k gives you 7k, and plus 4 as it is. So this is a quadratic equation that needs to be solved. And you can simply solve the quadratic equation using your calculator. So you'll get the value of k as 4 and k as negative 1 over 2. So these are the two values of k that satisfy this particular equation or this particular geometric series. It's in the next question, it says evaluate the sum. This is a summation which is given from r equals to 1 till 15, 3 times 2 power r. All you have to do is expand the summation and see what is the geometric relevant series. For example, the first thing you need to put r equals to 1 in this becomes 3 times 2 power 1. Next, you put r equals to 2, it gives you 3 times 2 power 2. Then you put r equals to 3, it gives you 3 times 2 power 3, and so on until you get till r15, which gives you 2 power 15. So if you expand the sequence, it gives you 3 times 2 power 1 is 6, plus 3 times 2 power 2 is basically 2 power 2 is 4, 4 times 3, 12, 3 times 2 power 3 is 8, 8 times 3 is 24, and it goes until the 15th term, which is basically 2 power 15 times 3. The answer is 98304. Now we need to find the sum of the series, and just to check whether it's a geometric series, it is indeed a geometric series. The next term is just generated by multiplying 2. So we know this is the first term, we know this is the 15th term, so we just need to add all these terms until the 15th term, which means we just need to find the sum of the first 15 terms. In this case, I know my n is 15, I know my u1 is 6, which is the first term, and my r is 2, which is the common ratio. And as I said, my r is greater than 1, the formula that I'm going to use is s of n equals to u1 r power n minus 1 over r minus 1. So let's substitute the values in. So s of 15 equals to u1 is 6, r is 2, power n is 15, minus 1 over 2 minus 1. If you simply put this in the calculator and try to solve this, you will get the answer as 196602, which is the sum of the first 15 terms of the series. Very straightforward. The next question is, it says that a geometric series has a common ratio of 1 over 2, and the sum of the first 4 terms is 36. Find the first term. So it says a geometric series has a common ratio of 1 over 2, and the sum of the first 4 terms, which means s of 4, is 36. So we have to find u1. Now we know as my common ratio is less than 1, so the relevant formula in this case is u1, 1 minus r power n over 1 minus r. So let's see what values we have been given, and let's try to substitute them in the equation. So I know my s of 4 is 36, which means my n is 4 in this case, and my r is 1 over 2. So let's try to find the value of u1. So s of 4 will be equals to u1, 1 minus 1 over 2 power 4, because my n is 4, over 1 minus 1 over 2. So if I just simplify this, s of 4 I know is 36 equals to u1. So 1 minus 1 over 2 power 4 in decimals is simply 0.0625. And 1 minus 1/2 is simply 0.5. All I need to do is just solve algebraically. This goes here. So my 36 times 0.5 gives me 18. This is my u1. 1 minus 0.0625 will give me 0.9375. Now this thing just comes under this, and my u1 becomes 18 over 0.9375, and my u1 simply becomes 19.2. This is my u1 in this case. But if I want to write in fractions, this is simply 96 over 5.